Okay, here we're going to be testing claims about a population mean, hypothesis testing, and we need to first check our data or whatever they're giving us to make sure it's normal or that it's greater than 30, and then if it includes this population standard deviation or not. So I don't see anything in here about normal, but I do see n is equal to 84, which is greater than 30, and there is no population standard deviation, so we're using a t-statistic. If the population standard deviation was present, and it was normally distributed or greater than 30, then we could use a z, but we're using a t-statistic here. So first I'm going to go through and show you how to do it in Statcrunch, and then I'm going to quickly show you how you would make claims with this t-statistic and the critical value with the long way with the chart and stuff. And then we'll do another example with all of Statcrunch. Dataset includes the data from the student evaluations of courses. The summary statistics are n is 84, sample mean 4.08, sample standard deviation 0.62, and we use a 0.05 level of significance to test the claim that the population of student course evaluations has a mean of equal to 4.25. Assume a simple random sample, identify the null and alternate hypothesis, test statistic p-value, and state the final conclusion. Okay, well, it says that it was equal to 4.25, and it doesn't have anything about less than or greater than, so we're going to do equal to that as our null. It's always equal to, and then the alternative would have to be not equal to then. So that would be A. Now let's test that to see if this claim is true. We'll go through and determine the test statistic. Here in Statcrunch, it's pretty fast. You go to t-stats, one sample with a summary. There's a mean, and we have the sample mean, 4.08. We have the sample standard deviation, 0.62, and the size of 84. We need to get this right as 4.25, and then it is a two-tail test, right? Left and right, so not equal to. All right, there's our t-stat, negative 2.51, and then 0.0139, or 0.014 if we round up. Now the conclusions are made on the p-value. So if the p-value is less than the level of significance that we have, then we reject. If it's greater, then we do not reject. Our level of significance is 0.05. Our p-value is 0.01. The p-value is less than this level of significance, so that means it's in the tail, right? It's in the critical region. If you're looking at the normal curve, it's in a critical region, so this would be a reject of the null hypothesis. There's sufficient evidence to conclude that the mean of the population of student course evaluations is equal to 4.25 is not correct. So this initial right here, there's enough evidence to say that that's not correct. All right, now let's do it looking at the long way, kind of a chart, and then getting our critical value. Okay, and then we'll do a Statcrunch just the quick way. So basically, if we're going to get this t-statistic, we need the formula, and that's what's given in the book and stuff for a t-statistic. There's a formula, and it's right here. It's the sample mean minus the population mean divided by the sample standard deviation over the square root of n. So I put all the information in already, and I have the same exact t-statistic. Let's just put it in here, the calculator, so you can see how it works. I would just do the numerator first. So 4.08 minus 4.25, and then I hit enter, and then I'm going to divide it by a parenthesis of 0.62 divided by the square root of 84. And then I'm going to go out, so it looks like that. Negative 2.5130, there it is. So that's how we do it with the formula. Okay, and then we need a test or critical value. It's a two-tailed test. So look at the graph here now. We have area on this side and area on this side because of the two-tailed test. So we need we could get two test statistics for this, the negative version and the positive version. But we'll get one and we just add the negative or get the positive, the opposite. Now that's found on the chart. Bring up a t-distribution. Read carefully. This is the area in to the right of the tail. So actually, this is this area we're finding. That's what this chart gives me. Some of them give you both, two tails. Some of them just give a one tail, so be careful. Read it. Degrees of freedom, n minus 1, 83. Go down to 83. Oh, I don't have 83, but I have 80. That's as close as I get. Don't go up, always go down to the nearest. Now, it's a two-tail test, so I don't use 0.05 because this is just one tail, right? All of it is not in one tail for us. Ours is this one. It's split. So 0.025 is in one tail. 0.025 right there and go down to 80 is 1.990. 1.990. That's my critical value. And so the opposite critical value of the left-hand side is negative 1.990. So those are the two critical values, the negative version and the positive version. Now I look to see what kind of test statistic I have. Well, it's negative 2.51. If that test statistic is less than the critical value, then we reject. If the test statistic is less than the critical value, we reject. It is less than, so we reject the null hypothesis, same as we did with the p-value. If it was in this beige area, we would not reject. So we split the significance level in half because it was a two-tailed test for this area. You know, if it's not a two-tail, you don't have to split it in half. Now let's just confirm this using Statcrunch. And how I would do that, again, you know how to find the t-stats one sample with summary. That's how you're going to find the t-statistic. We already did it, but since it's quick, I'll do it quick. 4.08, 0.62, 84, 4.25, not equal to compute. There that is. We go to stat calculators, t, to get the critical value. Degrees of freedom, 83. We want, well, we have a negative t statistic, so I'm going to look for the left side of that tail, okay? So when we're looking at this portion here, I'm going to try to find this one, right? The left portion. So I want the less than or equal to. I could find the right, but I'm going to find the left, and I need that to be 0.025, right? Half of it is on the right, and half of it's on the left. Negative 1.988. And if we look at what we got, negative 1.99, if we just look at rounding this, 8 rounds the 8 to a 9, negative 0.199. We've confirmed that this is the correct critical value, and it can be completely done in Statcrunch in basically 10 seconds if you know what you're doing. You get the Z statistic right there, and you see that it is to the left. You reject the null hypothesis and you're done. If this would have been to the right of this in the middle, in the gray area here, we do not reject. Okay, let's try this problem where we're doing another t statistic. We're going to test the claim with a t-statistic, but Statcrunch 100%. Test the null hypothesis that mu is equal to 50 versus the alternative hypothesis mu is less than 50. So a one-tailed test. N is 26. Population is known to be standard, normally distributed. All right, so we pass the first thing for a t-statistic, right? It's normally distributed, although N is less than 30. That's fine, as long as it's told to be normally distributed. And then no sample or no population standard deviation, excuse me. They give us the table, but we're going to use Statcrunch completely for this. So let's go in here. Now that we know all that, we're going to do a t-stats with one sample with summary. Fill in our values. Our sample mean is given right in A, 47.1. Sample standard deviation, 13.1. And the sample size was given as 26. This is a equal to 50. And then a one-tailed test saying they're less than 50. Compute gives us our t-stat. negative 1.287. 7 rounds the 8 up to a 9, negative 1.129. Now we need that critical value to make some determinations. They say the researcher decides to test the hypothesis at 0.1 level of significance. So remember, this is a one-tailed test, and it's on the less than, so left. So we're only going to have one tail. So in the other case, we had two tails. We had to split our level of significance. All 0.1 is in here. No splitting this time. And that kind of gives away the answer here, right? I mean, it makes sense. We just know that's to the left of that one value. But what is that critical value? That's a T calculator. Calculator T. Degrees of freedom, 1 less than N. 25. Go left, because we're in the left tail, left area. We're going to find that value, and we want all 0.01 to be in that tail. Negative 1.316 is our critical value. That's right where the 0.10 level of significance is. Now we do a little comparison, right? Is our T-stat less than that? Is it in the blue area, the shaded area? If so, reject the null hypothesis, right? Just like last time, if it's in this blue area, reject. If it's in this beige area, do not reject. Well, negative 1.129 is in the white or beige area. It's not in that blue. It's not less than this critical value. It's actually greater than that critical value. It's here. So we, in this case, do not reject the null hypothesis. No, we will not reject the null hypothesis because the test statistic does not fall in the critical blue region. So there's sufficient evidence to support the null hypothesis. Okay, hopefully that helps with Statcrunch and hypothesis testing on population means.